to Florida, Jacksonville. This is the headquarters for Made in Space, and it's a pretty amazing place. I was here for like a month and a half before I even got inside the building to see it. Because we had a mandatory work at home, and I was actually working there for about 2 weeks, a couple of weeks ago, and then we were sent home again. So Jacksonville, up until about 30 days ago, had 1,700 cases. So through the worst part of the pandemic, it only got up to 1,700 and like 30 or 40 deaths. And then now we're at 18,000 in 30 days. So it's stupid virus. Yeah, so I'm gonna, one last thing on it. I can share my screen.
The Greek gods will punish you for your impudence. Hubris is the word.
So I did want to just leave you guys with this. If you go to YouTube, type in Dr. Martinson. Dr. Martinson is someone I've been following for 15 years from a financial standpoint, but he actually has a doctorate in virology, amazingly enough. So when this came on the scene, he was doing like 5 episodes a week, 35, 40 minutes long, digging deep into the actual facts and not all the BS you hear on the actual news channels. So I highly recommend everybody go there and take a look at it, especially he was talking about coronaviruses. You really can't get much of a, vaccine. They never came up with a vaccine for the common cold, for example. And then the flu that comes around, that's a coronavirus too, and they have to give you a new vaccine every year. But there's been some new research came out last week that T cells, which can last up to 10 or 11 years in the body, it looks like if we can create a vaccine around T cells, then we may have a shot at, something. So anyway, I just wanted to share that. Let's see. So we have a new board. This is it. Dr. Ting should be very happy.
Okay. A newborn.
Yeah. Well, I think I figured out all the hardware problems. The biggest problem with using that little surface mount board has to do with the reset. So this is a version 4 board. My version 3 board, which I was working on, and the more I thought about it, I said, I don't want to make any more of these boards. They're very expensive to run these boards. So I just said, screw it, and went to this board. But I have another board that I think probably would work if I were to spin it, but I gave up on that to go with, because if we use the off-the-shelf board, you can program it, use all the tools, like Dr. Ting said a year ago. So anyway, yeah, he's been hitting me upside. He's been hitting me upside the head with the 2x4, and finally I woke up. So, so these boards are completed. They're in transit to me right now. I will power them up and make sure that everything, at least test some of the basic hardware on it, make sure I can flash the LED, his eyes, and do some other things. And then once that's done, I'll be sending 2 boards to Dr. Ting and 2 boards to Brad. Dr. Ting, I need your address.
Okay.
Can you
okay, I'll email it to you.
Okay. And then anyone else who purchased boards, email me your address. It's Donald R. Golding at gmail.com. And let's see. anyway, it's, maybe I should do it this way.
And you read the list, the email list, right? You can just post to the email list or on Meetup. If you post to Meetup, I'll forward it to Don. Because I don't think Don's on Meetup reading messages.
Yeah, so I will definitely post everything to the SVFIG, but if you want to contact me directly, that's my email right there. So I had 32 boards made, so we have plenty. I will be donating some to the group. If you're a financially challenged fourth guy and you want to play with the board, send me an email, you know, and we'll make sure we get a board to you. You can play with it. This is not a for-profit project. I'm in the hole a lot. So.
It looks like a nice board.
Yeah, I think it turned out really good. So there's a lot of ground plane to it. So it should be, you know, pretty clean. And so that's the top side. That's the bottom side board. And I think the dimensions are the same. Let's see, it's 2.185 inches. I think it's 6. Yeah, 6 inches. Does anyone need to know the functionality of the board that hasn't heard me talk about that before?
Yeah.
Might be a good idea to write up a spec sheet and post it to the list.
Yeah, I'll have to do that for sure. Yeah. So anyway, it's got four eyes on it, 4 LED eyes. So you have an LED and an opto receiver, like a Photo Darlington. It's got a speaker, a microphone. It's got a inertial guidance chip on it. So you have magnetic compass, and you also have accelerometer and inclinometer on it. We do have a single channel of sonar, and it can handle 2 12-volt DC motors up to, you know, like a couple amps or so. Most robots, you know, will only use a half an amp or something like that per motor, very small motors. So
which motor driver chip did you use?
I rolled my own. So
okay.
Here's the schematic. So this is the it's not the motor. So this is the motor here. So basically I'm using these a 7405, which is an open drain, open collector type chip. And so that changes voltages from from CMOS levels to 12 volts. And then it's an discrete H bridge. This is, it does monitor the current in each motor. So the entire chassis of the robot is a sensor. If it hits something, or it can even, it's sensitive enough to go from a hard floor to carpeting and actually know that that has happened, because the current goes up on carpeting. So it can sense that. And then, so this is a microphone amplifier. This is the sonar amplifier. So use the electric type microphone, separate transmitter and receiver pair for sonar. These are 2 half bridges that come out to a connector. So what we could do with that is you can use actually hobby servo motors and hook them up to here. And then all you do is you pulse width modulate. And then depending on the duty cycle is the position of a hobby type motor. And so this gives you two degrees of freedom. You could put the sonar on a pan and tilt head if you wanted to. And over here is very simple. This is the robot eyes. And so it's just simply an LED and a photo Darlington on there. I used a 0.1 inch spacing, so it's a standard type header. So you can actually put a socket in here, and you can put arrays of sensors. So you can alternate, LED, phototransistor, LED, phototransistor. You can make an array, and you can actually make a larger robot or a larger area. There's 4 channels because you're going to have 2 going forward and 2 looking at the side for the instinct level to work. And this is I'm using an LSM 303, which is the inertial guidance system type chip. So that gives us the magnetic heading information and also inclinometer and accelerometer. So the robot knows if it runs into something. If you pick it up, the robot could react to, like, if you're going like this with it, it could make different like noises, like maybe it's happy. You make a happy noise if you're playing with it. So the whole idea, my concept of robotics is we want them to be like animalistic or anthropomorphic. That makes a much more interesting robot, and it also makes a more robust robot for doing collision avoidance. So Dr. Ting and Brad have put a lot of work into taking the Whiskers code that was running on a 688C11 back in the 90s, and now it's running on this powerful 32-bit processor. It's just going to be amazing what we can do with it. So this is the processor board right here.
So Don.
Yeah.
Obviously, they twisted your arm to go to Florida. They really feel and know that you're quite valuable. Now, when this thing comes to fruition, how is it actually going to help the company?
Oh, you're talking about the board here?
Yeah, you're doing all this. You're doing all this work. What's the end result going to be?
When you get past 60, you start thinking about your legacy.
Yeah.
Nobody on this call has been there, I'm sure. I just thought Forth is a tremendous language. It's an incredible language for robotics, and for a language to succeed, it needs a killer app, and robotics is Forth's killer app. So even though that Forth isn't used in embedded systems much today, I'm making this open hardware, open source, so we can get the maker community on board. And the idea is they can grab it and run with it. They can download the Forth and language that we're going to provide to them and show how an intelligent robot works. And I double dog dare the C guys out there to come up with and they will. I'm sure they will, but it'll take them some time to come up with something similar, but it won't be programmable, right? It'll just be running. C just runs code. It's compiled language. You compile it. You make a change. You gotta compile a new binary and download it to the processor. That ain't gonna cut it for an intelligent machine. Intelligent machines got to incrementally compile and remember, and things like that. So I want this as a platform for doing AI robotics research. So I have registered AI bot. I think it's .org or .net, one of the two. So at some point we'll have a website. We'll start promoting in the maker community. I have probably 5 or 6 people in Made in Space. I gave a presentation that lasted over an hour and a half about a few weeks ago to the software group. And this is how I opened it. You know, we use strictly C, C++. So I said, okay, you got 100 robots that are out making things, mining out at Pluto, right? Or Mars. Well, it takes, you know, how long does it take for a signal to get there? And what's the bandwidth of that signal? So
Right.
if you compile a C binary and you send that through space and download it to the robot, and you got 100 robots to update, all with different code, how long is that going to take?
So
Whereas-
perhaps this board will help open the back door to get forth into space.
Yes, again, because Forth has a very strong heritage in space, actually, very strong. If you put in NASA and Forth, or put in NASA and RTX 2010, you'll see that there's a lot of Forth in space. There has been. So I have people at Made in Space that are actually interested in this board. I'll be providing them with, I probably have 5 or 6 people that want to buy the board here at Made in Space. I've been kind of nudging them a little bit along the way about Forth and how it could be an advantage to the company. Obviously, when you're talking about competing with other companies, you know, you want to build up IP, and you want this IP to be substantially better than your competitors. So if we had, at least if we had Forth as the executive part of the robot, we could update software very easily, you know, in remote locations. And the fact that it's an incremental compiler, it's interactive, you know, so, and we have to use low-speed data links, even in low Earth orbit. So our first project, which is Archinaut 1, which I'm designing the computer for that, and I'm just getting into layout now. I finished the schematics. Archinaut 1 would be, it would be nice to have Forth running on the outside, but even in low, Archinaut 1 is going to be in low Earth orbit, and even at that, when they talk about a data link to talk to Archinaut 1, we're going to only see it like 5 minutes, you know, out of an hour and a half or something like that, you know, because it's swirling around the Earth, right? So the data link is an issue in space, and there's no other language that could use this, you know, a minimal amount of data link than Forth as far as updating software goes. So I'm nudging them.
Very nice, very nice.
So I really hope that the Forth community gets behind this project. You know, Ting and Brad are already involved in it, and there's 3 or 4 other people bought boards. So if we can start showing how you can build, and who was it that's working on Cozy? Cozy?
Bob Armstrong, and to some extent, I think Sam Falvo is interested.
Yeah, so
Yeah,
if those guys could
I certainly would love to get any projects, particularly little, you know, start things to go and make demos of the fact that you can go and write things at an extremely, at the APL succinct math level, And one of the things, whether it's for prototyping to get the algorithm right, but also to go and do things like edit the forth that you're getting to minimize the amount of code you've got, eliminate any, you know, extraneous words, and sort everything into dependency orders and all of that. Definitely. That's what Cozy needs right now more than anything else, is some tasks.
Well, this would be, I think, a good platform for it.
Yeah, I think it would be dynamic. Yeah, yeah.
That too.
I wanted to make the point that this is not a made in space project. This is a personal project led by Don.
Right.
Yeah, I think, you know, Don, if you, I just want you to be able to reproduce the whisker on this board, okay? Yeah, if you can make a whisker out of this board, I think I love it. I think people will love it, and we have something to go from there. I think the you know, the whisker is a beautiful machine. I just would want to have it in my hand.
Yeah, I know. I have only been promising for a year now, but it's finally here.
Yes.
Yeah, so when I designed the new board, I designed it to have all of the capabilities of Whiskers Plus. Whiskers did not have the initial guidance system chip on it. It didn't have sonar. And Dr. Ting is already making it sing and dance, even though he's just using his little breadboard. I was really impressed with the audio stuff that you did, that you demonstrated, you know, last year. So it's going to be a lot of fun, and I've shared the curriculum for Whiskers, which is only 10 hours in length, and in 10 hours, if you know English, which means you could be like in the 7th or 8th grade, you could actually take the curriculum and you would learn the basics of programming, because we have a chapter on doing loops. We have a chapter on variables and constants and defining a new word. And at the end of every chapter, there's a problem that the students have to solve. They have to write code and solve a problem. The code is, you know, a page worth. It's very little, but like, you know, to make a box is one. So that under the loop chapter, you make a box, right? So it's pretty easy code. It's, you know, forward 1 foot, right turn, 90 degrees right turn, and then forward, and you put that in a do loop, or it'll be a for next. Don't hit me, Dr. Ting. It'll be in a for next loop in the version for this one. But we're teaching young kids to code. Can you imagine teaching a 7 or 8, you know, 8th grade student C? They would go screaming into the night. So anyway, there's a lot of opportunity to do some neat things. I sold 2,000 Whiskers in the education market. This board will, I think, be a big hit in the education market. So I'm gonna, once it's matured, I'll contact distributors that I know, the big ones in the education market, and see if we can get that going again. Universities would be interested in this. So so yeah, I think I'm pretty excited about it. It's my legacy.
Yeah.
Now,
Yeah. Just the Whisker 2 or Whisker 3 or Whisker Plus. Just make it happen.
so the last part of my talk is I want to talk to you. So at work, what I'm doing is we're using an FPGA because FPGAs are space rated. The cost of a microprocessor that is space rated is very high, and can even be higher than an FPGA. So FPGAs dominate space right now. as far as being the controller. Many times they put it, because everyone likes to, you know, code in C or C++, they typically will put a processor core in it. So I convinced companies using the RISC-V core in ours, but we're doing a lot of the coding in system Verilog, which means, you know, in an FPGA, when you system Verilog, each process that runs, say, each motor and each sensor is running at 100 megahertz. There's no multitasking problems. So with that said, I am interested in building a board, and it'd probably take another year, but an FPGA-based board that will have parallel flash and SRAM for speed, not DDR, which is, DDR runs a quarter of the speed of SRAM. So it would have SRAM and then flash, and it would be basically a supercomputer board that we could put Dr. Ting's FPGA forth in it, and then do some really high level, it'd just be a screaming fourth processor.
Don, why is that FPGAs are frequently rad hard rated? That's fascinating.
It has to do with the way they manufacture things. So the interesting thing about space is we have to deal with -55 to +125. We have to deal with 100 K-rad environment, and there are protons and electrons flying around in space, flipping bits in your processor. It's pretty nasty. On the earthbound microprocessors have gone to smaller and smaller geometries. The smaller the geometry, the more susceptible to space radiation. How about that? So you want to use the latest and greatest, you know, i7 processor, forget it. It'll get zapped in space.
And there are particular families of these chips that are optimized for the space environment.
Yes.
Nobody's really done that with a processor since about the time of the Harris RTX spaceborne processor. Shortly after that time, nobody was making really an effort to design processes and implementations of spaceborne processors in this country, at least. I can't speak to those other people elsewhere.
Yeah, you're right. So we're actually using a SAM7. There's a rad hard SAM7. There are some sprinkling of rad hard processors out there, but the space community, you know, we might buy tens, maybe 100 per year. So it's just not worth it for anyone to support it. But the FPGA guys, both Xilinx and Microsemi, you know, have rad hard, rad tolerant chips. We're using the RTG4 from Microsemi, which is a flash-based FPGA, and I believe it's more robust than the Xilinx, but there's a lot of Xilinx flying. So Xilinx is based on SRAM rather than a flash memory or its configuration, and RAM is more susceptible to having bits flipped from radiation and particles running around than flash is. So I chose that. I was in charge of the computer, so I chose that. There's some talk of switching back to Xilinx, but not my call. And we're talking about the next mission. Archinaut 1 will have the RTG4. Yeah, that's set in stone. So it's an amazing company. Oh, the one last thing for Made in Space is about a month ago, we were actually merged. If you do a search on the internet called Redwire, let's see. So we actually were merged with 2 other companies, which makes us over 200 employees. So company called Deep Space Systems. They're in Colorado. I think they have 60 people. They have an enormous space, deep space heritage. So they've worked on a lot of different control systems and electronics for deep space probes. And then Adcol Space is another one. So these 2 companies combined are about 100. And this entity here, this AI Industrial Partners, is the deep pockets. So these guys are kind of like a they're not a hedge fund, but they're kind of like a venture capital type fund for like pension funds and stuff like that, or big guys like that. So these big guys invest in AI Industrial Partners, and then they take their money, and what they like to do is they wanted it to create like a middle tier entrepreneurial space company that can compete with Northrop Grumman, Lockheed, and that sort of thing, but focused. We're Made in Space is very focused in manufacturing things in space, and Boeing and Northrop, I'm not aware of much going on with them in that particular space. And Made in Space is 10 years old, and we dominate that area. So it's pretty interesting. Any questions?
Oh, I do have a question. Is there a benefit of, because I've read somewhere that SpaceX actually uses just regular x86 processors, but what they do is they have 3 of them, and the 3 computers are redundant. They're exactly the same, and they vote on what to do. So even if one of them was zapped, then...
That's a solution to bit flips to a certain extent, but you can calculate how often that will go off the rails. And if you're completely if that's your only solution, if on the other hand you're talking about the radiation induced aging and failures other than bit flips, it's not any kind of a solution to that. So you have to decide what kind of environment you want to be operating in, and how long you're going to be operating in it before you use that kind of solution.
Got it.
Yeah, the space shuttle used that same approach. If I was at SpaceX, I would be using FPGAs for sure. But anyway, I'm not. My son, by the way, just got hired at SpaceX. Just got his letter.
Oh, wow. What does he do?
Well, he worked at a company that made fuel valves and stuff like that for commercial aircraft, and he's going to be doing that kind of stuff at SpaceX.
Okay, great. Yeah, I'll send you an email with my address, and look forward to the board, and then to the reference design of the next generation of Whisker, and hope that that we can push that into everybody's hand, and then we'll all have fun.
Yeah,
Thank
I did
you.
it in Eagle 7. So that's what the board is done in, and I will make all the file schematics and PC board stuff available for people.
Yeah.
This is what I'm working on. I'm working on the computer piece of this. That's our out. It's making a 10 meter, which is almost 100-foot solar panel. That's the largest solar panel ever in space. and we're going to make the first one. And then,
Okay, so let's wrap it up. John Peters wanted to do a little demo at the end, although it wasn't on the agenda. Going forward, let's try to get these things announced in advance. The email list is the best way to do that. But thank you, Don. Do you have closing remarks?
no, I'm just very excited about what's going on, my future, and getting the board done and getting some of you fourth guys to work with the board. A lot of good stuff going on. So keep in touch.
Yeah.
You want to say a few words about the presentation you were talking about doing this month that I asked you to push till next month?
You talking to me?
Yes. You wanted to talk about something.
I think that was the supercomputer. I just kind of that was probably it.
Okay, well, we'll be pleased to hear about it next month. I'll look over the email thread from the email list and remind you of it when I'm searching for content for next month. So, John,
I'm getting old, so you know.
don't go too much past 3, because some of us have other places to be, I'm told.